Hey Dr. Lane, so I'm going to do a reassessment for Chapter 4. I picked a problem out of the back of the book. It's from Chapter 4, number 27 in the back of the book, and it reads, 1 mole of tungsten has a mass of 184 grams as shown in the periodic table on the inside front cover of the textbook. The density of tungsten is 19.3 grams divided by centimeters cubed. What is the approximate diameter of a tungsten atom in a solid block of the material? So from what they gave us, I did my calculations. Let me get this straight. There you go. So I did my calculations, and first, from the density they gave me, I converted it to kilograms per meter cubed, and you could see I multiplied by the correct units. And then from that, I have 19.3 times 10 to the third kilograms divided by meters cubed times 1 mole of tungsten, which from the periodic table it's 1.84 kilograms. So I just changed grams into kilograms. I just moved my decimal place over 3 times, and I multiplied by 1 mole, which we have atoms, and that gave me 6.314 times 10 to the 28th meters cubed. Now, since a cube is length times width times height, you have to take the cube root of that to just get the one edge of a cube. So I do that, and I get 3.98 times 10 to the ninth atoms. So when it says that a row of atoms is 1 meter long, I have to take the inverse of that to get the diameter. So I do that, I take the inverse, and I get 2.511 times 10 to the negative 10th meters. So that right there is the diameter of a tungsten atom, and you can see all my calculations that I did there. Then for the second portion, I did another problem out of the book, and it's number 42. It reads, 2 wires are made of the same kind of metal. Wire A has a diameter of 2.4 millimeters and is initially 2.8 meters long. You hang an 8 kilogram mass from a wire. From wire A, measure the amount of stretch and determine Young's module to be 1.37 times 10 to the 12 newtons divided by meters squared. Wire B is made of the same kind of metal as wire A, has the same length as wire A, but is twice diameter. You hang the same 8 kilogram mass from wire B, measure the amount of stretch, and determine Young modulus YB. And then it's asking which is the following. So it is a multiple choice question, but I wrote down my Young's module formula, and I wrote down all of my units. Now, if I were to plug them in, they didn't give me the stretch. They gave me everything else. But if I had the stretch, I could actually plug it in, and I could prove that these two values would be the same. YA, like Young's module for A, is going to be equal to Young's module for B. And my reasoning I wrote at the bottom is because the 2 wires are made of the same material. Doubling the diameter, or doubling the measure of the diameter, would result in the length of the amount of stretch being longer. The wider the diameter, the less stiff the wire is going to be, but essentially the 2 wires are the same if the correct variables would be plugged in. So that's what I did for the second one. So that's all I got. Thank you.